We stand at a remarkable moment in human history. It feels like the dawn of a new era. For centuries, we have looked up at the stars and wondered about our place in the universe. Now, we are turning that same sense of wonder inward. We are exploring the cosmos within our own selves. A powerful new ally has joined us on this journey. It is called artificial intelligence, or AI. This tool is not made of flesh and bone, it is made of logic and data. It can see patterns that our eyes might miss. It can process information at speeds we can barely imagine. This opens up a universe of new possibilities for medicine and for health. Imagine looking forward, just 2 decades from today. Today is May 10, 2026. Let's look to the year 2046. In that future, we may see a world transformed. A world where many of the diseases we fear today have lost their power. Even now, AI is working silently behind the scenes. It is an invisible helper in the quest for better health. Think of it as a super-powered microscope. It does not just magnify what we can see. It reveals hidden connections in vast oceans of biological data. For example, when a doctor looks at an X-ray or an MRI scan, they are searching for subtle clues. They are looking for the faint shadow of a tumor or the early signs of disease. An AI can be trained on millions of such images. It learns to spot these signs with incredible accuracy. Sometimes it can even find them earlier than a human expert. This early detection is a game changer. It gives us a crucial head start in the fight against illness. Another fascinating area is the study of our genes. Our DNA is like a giant instruction manual for building and running our bodies. But it is written in a language we are still learning to read. AI acts as a brilliant translator. It can scan through thousands of genomes. It can pinpoint tiny variations in the genetic code that might lead to disease. Scientists use this information to understand why some people get sick while others stay healthy. This knowledge is the first step toward developing new cures. AI helps us find the right page in the book of life. It points us directly to the source of the problem. AI is also transforming how we discover new medicines. In the past, finding a new drug was a slow and expensive process. It was like searching for a single key that could unlock a specific door, but you had a pile of millions of keys to try. Scientists had to test countless chemical compounds in the lab, one by one. Most of them would fail. Today, AI can do much of this work inside a computer. It can simulate how millions of molecules might interact with a diseased cell and predict which ones are most likely to work. This narrows down the search dramatically. It saves precious time and resources. It accelerates the pace of discovery. Let us chart a course for the next 20 years. What might this voyage into a healthier future look like? We can imagine the journey in stages. Each stage builds upon the last. This timeline is not a prediction set in stone. It is a map of possibilities. The journey begins now, with small but significant steps. It is a story of steady, accelerating progress, driven by the partnership between human ingenuity and artificial intelligence. In the first 5 years, from 2026 to 2031, we will see AI become a standard tool. It will move from specialized research labs into mainstream hospitals and clinics. Doctors will routinely use AI assistants to help diagnose diseases from medical images. Pharmaceutical companies will all use AI to guide the early stages of drug development. We will see the first wave of AI-discovered drugs entering human trials. Early victories will likely be in areas like rare genetic disorders and specific types of cancer. This phase is about integration and validation. The next stage, from 2031 to 2036, will be a period of acceleration. The tools we built in the first 5 years will mature. AI-guided drug discovery will become the norm. This will lead to a pipeline of new therapies for a wider range of conditions. We might see major breakthroughs in treating neurodegenerative diseases like Parkinson's or Alzheimer's. AI will help us untangle the complex factors that cause them. Gene editing technologies, guided by AI, will become safer and more precise. We may begin to see treatments that can correct genetic defects at their source. This is the stage where the promise of personalized medicine starts to become a tangible reality for many. In the years from 2036 to 2041, the focus will shift from treatment to prevention. AI systems will continuously monitor our health data from wearable sensors, genetic tests, and regular checkups. They will create a dynamic picture of our individual biology and act as early warning systems, alerting us to potential issues long before they become serious problems. They might suggest subtle changes to our diet or lifestyle, or recommend a specific preventative therapy. Medicine will become deeply personal and proactive. Finally, as we approach 2046, we may reach a profound turning point. Many major diseases could be rendered manageable, preventable, or even curable. AI will extend our life and our health. To see the future, we can look at the pioneers of today. Scientists are already harnessing the power of AI in their labs. They are the trailblazers on this new frontier. One prominent example is David Sinclair, a biologist at Harvard University. His work focuses on one of the most fundamental biological processes of all: aging. He views aging not as an inevitable fate, but as a condition that can be understood and potentially treated. In his search for ways to slow down or reverse the clock of aging, AI has become an indispensable partner. It helps him navigate the immense complexity of the aging process. Dr. Sinclair's lab generates vast quantities of data. They study how genes turn on and off in aging cells. They test thousands of small molecules to see if they can restore youthful function. Manually analyzing this data would be an impossible task, like finding a single grain of sand on all the beaches of the world. AI can comb through this data with superhuman speed and precision, identifying subtle patterns that reveal how a drug affects aging pathways. This allows his team to quickly zero in on the most promising compounds for further study. This is not science fiction. This is the daily reality of modern biological research. The AI does not replace the scientist. It empowers the scientist. David Sinclair and his team still form the hypotheses. They still design the experiments. They still interpret the results with human wisdom and intuition. The AI acts as a powerful computational engine. It performs the heavy lifting of data analysis and suggests new avenues of inquiry that a human might never have considered. This approach is spreading to labs all over the globe. Researchers studying cancer, heart disease, and countless other conditions are adopting similar methods. The ultimate goal of this medical revolution is not just to help us live longer. It is to help us live better. There is an important distinction between lifespan and health span. Lifespan is the total number of years we are alive. Health span is the number of those years that we spend in good health, free from chronic disease and disability. In the past, increases in lifespan have often come with a longer period of sickness at the end of life. The great promise of AI in medicine is that it can help us extend our health span. Imagine a future where a simple blood test, analyzed by an AI, can detect the molecular signatures of cancer when it is just a few hundred cells. Or a smartwatch that can predict a cardiac event weeks in advance. By catching diseases at their absolute earliest stages, we can treat them more effectively. AI will lead to better and more personalized treatments, selecting the perfect drug at the perfect dose, making care more effective with fewer side effects. AI will empower us to take control of our own health, translating complex information into simple guidance, offering gentle nudges, and helping build a culture of wellness that adds more healthy, vibrant years to our lives. As we gaze further into the future, our 20-year timeline leads us toward an even more speculative and mind-bending horizon. Some futurists and technologists talk about an event they call the singularity, a hypothetical point when AI undergoes runaway self-improvement and transforms civilization. A date often associated with this idea is 2045. It is a concept that inspires both great excitement and profound caution. If such a superintelligence emerged with goals aligned to human well-being, the implications for medicine could be staggering, solving biological puzzles that currently seem impossible, understanding every cell, protein, and gene with perfect clarity. It could design cures for all diseases, not just some. It could devise methods to completely halt and reverse aging at a molecular level, raising the possibility of biological immortality. This does not mean we would be indestructible. It means no longer being subject to death from old age or disease, aging as a treatable condition, with tissues repaired or regenerated perfectly. This is an idea of cosmic proportions that would change what it means to be human. These are possibilities, not predictions. The path to a technological singularity is far from certain. The concept of biological immortality raises monumental ethical questions. Who would have access? What would it mean for society and our planet? For now, these questions remind us of the transformative potential we are beginning to unlock, the distant stars we navigate by as we take our first steps. The journey ahead is filled with breathtaking potential. The prospect of ending many diseases within a generation is a powerful and worthy goal. Every powerful technology comes with responsibility. We must develop and deploy these advances safely and ethically. The best future is one where technology enhances our humanity, where AI extends our life and our health, and in 2 decades, we may conquer diseases that are today incurable.